είχε πέρα από το ώρες, ας πούμε, ξέρω, ότι έκανες κάτι, ξέρω εγώ, που έμεινε στην ιστορία, δεν είχε κάτι άλλο. Δεν θα μπορούσε να έχει κάτι άλλο.
Δεν ξέρουμε κάτι να του δώσουμε την αξία που του πρέπει. Αυτό το εγχείρημα η Ελλάδα έπρεπε να μην μείνει προ 25 πόσο χρόνο έγινε και τέρμα. Έπρεπε να το έχει πραγματικά μπροστά. Και τώρα έρχονται 10 ποδηλάτες, 10 τρελόπεδα, ας πούμε, στη Θεσσαλονίκη, να το ξαναθυμηθούν.
On the Greek island of Crete, an airplane waits.
Whoa, whoa, whoa! Be careful walking around the airplane, never look away from it.
It's a delicate, pampered machine, attended by a team of more than 40 designers, builders, pilots, and helpers.
Listen for that rubbing in flight. If you hear any rubbing, we need to know.
They have spent 3 years and nearly $1 million preparing for a single 72-mile flight across the Aegean Sea. A modest goal, perhaps, except for one. The engine is a human being.
Δεν είχε κανένα κινητήρα μέσα με χιλιάδες ύπους όπως έχει ένα τζετ. Ήταν ένας άνθρωπος που με τη μυϊκή του δύναμη πετούσε ένα αεροπλάνο. Ό,τι έκανε και ο Δαίδαλος.
Today is the final shakedown flight for this plane called Dædalus, to see if it's ready for a flight more than 3 times farther than any human-powered aircraft has flown before. The last unknown of a bold experiment in aeronautics, material science, and physiology. Everything that can be tested has been tested, but no one can predict a gust of wind or a muscle cramp or any other mishap. But then those who push the limits of technology have always courted disaster. A few miles away lie the ancient ruins of Knossos, where a mythical inventor named Dædalus was said to have been imprisoned 3,000 years ago, along with his son, Icarus. Dædalus built wings of feathers and wax so that he and his son could fly to freedom across the sea. But Icarus was overwhelmed by the power and flew too close to the sun, which melted his wings. While Dædalus, who flew with more restraint, made it safely across. Now the heirs of Dædalus hope to recreate his mythical flight, well aware that they might just as easily recreate the flight of Icarus. They've come to appreciate the difficulty of turning myths into reality.
Good flight, Canellis.
To have any hope of reaching their goal, they've had to create the most efficient human-powered airplane ever built. With a wingspan greater than a 727 jet, Dædalus weighs just 68 pounds and represents more than 75,000 man-hours of design, construction, and testing.
Εκεί μου ζητάνε μια τεράστια υποστήριξη, πλέον αρχίζοντας από τη μεταφορά του Δαιδάλου και της ομάδος, τη φιλοξενία στην αεροπορική βάση του Ηρακλείου, την υποστήριξη εκεί, τα πάντα και είχε γίνει επιλογή της ώρες με άπνοια, με θερμοκρασία αυτή που θέλανε, ιδανικά όλα. Υποστήριξη από ελικόπτερα, υποστήριξη ιατρική, από πλευράς νοσοκομείου αεροπορίας, μονάδος Ηρακλείου, μονάδος της Σαντορίνη αεροπορικής, όλα έτοιμα.
But the weather could destroy it all. The success of the flight will depend on being able to predict with certainty conditions that are very rare in the Mediterranean. Almost no wind for a period of at least 6 hours over a 72-mile expanse of open water. In preparation for the flight, 5 world-class cyclists have spent 6 months in training as pilots. Only one will have a chance to fly.
Αυτοί ήθελαν να είναι κάποιος ποδηλάτης καλός που να μπορεί να βγάλει μια πτήση σε μεγάλη ένταση για 7 ώρες.
Okay. Managing this effort is a big job in itself, coordinating the support of 38 corporate sponsors and the government of Greece, and supervising 43 team members earning minimal pay.
Υπήρχαν πάρα πολλοί σπόνσορες. Άλλοι βάζαν χρήματα, άλλοι βάζαν υλικά, άλλοι βάζανε... Ξέρω εγώ, σε εμάς που ήμασταν ποδηλάτες, μας έδωσαν ποδηλατικό ρουχισμό και τέτοια πράγματα. Μας έδωσαν μια εταιρεία, μας έδινε τις βιταμίνες και συμπληρώματα διατροφής σε αυτές τις μπάρες που τότε πρωτοβγαίναν.
It's an ambitious and sophisticated operation, but they're still up against the same difficult problems that have always plagued people who want to fly. In the mountains of Crete, eagles soar in an ocean of air. From the time of Dædalus on, birds were the obvious model for would-be flyers, who naturally assumed that they too could fly under their own power. But no one ever had much success with the flapping wing approach. The mechanical complexity and efficiency of a bird's wing is an engineering problem that has never been solved. Early flyers had better luck with the fixed wing and made glider flights off mountaintops in the late 19th century. By trial and error, the basic principles of flight were being learned. After years of experimentation with gliders, the Wright brothers made the first controlled powered flight in 1903 with a 12-horsepower engine. But the dream of human-powered flight remained elusive. Although for some, it was still an irresistible challenge. The attempts became more sophisticated, but didn't solve the problem. A 1937 German plane called Muffley had to be launched with a big rubber band, and the pilot could manage only an extended glide. It flew, but it couldn't be called a fully human-powered plane. Then in 1959, an Englishman named Henry Kramer offered £5,000 for the first flight around a 1-mile figure-8 course entirely under human power, including takeoff. Rules that would force designers to come to terms with the physics of flight. It begins with lift, produced by a moving wing whose shape or airfoil causes the air passing over it to travel faster than the air beneath it. This creates lower air pressure above the wing than below, causing it to rise. An aircraft needs to fly fast enough to produce lift equal to its own weight, with enough forward thrust to overcome the air resistance known as drag and maintain its speed, all of which requires a certain amount of power. More weight requires more power to produce more speed, to produce more lift. But the added speed also increases drag, requiring even more power to produce more thrust. The problem with a human-powered airplane, or HPA as it is called, is that it's stuck with a low-power engine, about 1/4 horsepower. British designers tried to compensate by emulating the low-drag design of gliders, but they were working with wood and ended up with small, heavy planes that soon exhausted their pilots. They did make progress. Sumpac made the first human-powered takeoff in 1961. In 1962, a plane called Puffin flew 993 yards, and the record stood for 10 years. It was beaten in 1972 by Jupiter, a heavier but aerodynamically cleaner design piloted by a strong athlete. But it couldn't turn very well. Control has always been a problem for HPAs because they fly so slowly, and Jupiter was no exception. The attempts continued in Europe and Japan. But there was a growing feeling that the rules of the Kramer competition were just too tough. Then in 1977, an American named Paul McCready unveiled a new concept. The Gossamer Condor required less power from the pilot because it flew more slowly than previous HPAs. It needed a large wing to maintain lift at this slow speed, but it was made of lightweight plastic and aluminum tubing with wire braces for strength instead of a heavy internal structure. After considerable work to solve control problems, the Gossamer Condor and pilot Brian Allen finally captured the Kramer Prize. Two years later, McCready and Allen won another Kramer Prize with the Gossamer Albatross by making it across the English Channel. Exhausted and dehydrated, Allen was barely able to finish the 22-mile flight, but willpower carried him to the beach and continued McCready's domination of human-powered flight. Back in Massachusetts, a group of undergraduates at MIT had been following McCready's progress with great interest. Model rocket and airplane builders since childhood, they saw human-powered airplanes as a natural step up in scale. In 1979, they launched their first plane, named Chrysalis. The Kramer Prize was on their minds, but 1 week later, the Gossamer Albatross made it across the channel on its first try. John Langford was an MIT senior in aeronautics at the time.
We were absolutely awed, but we weren't really sure where it left the field. We really had viewed it almost as a dead end in terms of the longer future of human-powered flight. It really wasn't until about 4 years later that the British, seeing that the field had languished after Albatross's accomplishment, offered another prize for speed. We were in a position to jump right into that based on our Chrysalis experience, and did so.
After a close race with McCready, the team from MIT won with a plane called Monarch at a speed of 21 miles per hour.
We were ecstatic about the success in Monarch, but we also felt like the airplane was a very compromised design. It was very rushed. It had been built specifically to win that competition and was designed completely around the rules. It was not in any sense the ultimate machine that could be built. It left us with a feeling of wondering what that ultimate machine would look like. And that actually led directly into Dædalus, because we took the idea of the ultimate airplane and applied it to what we saw as the ultimate challenge, which was a recreation of this mythical flight of 35 centuries ago that really forms the opening of any anthology of flight.
In 1985, with support from MIT and the National Air and Space Museum, the veterans of Monarch and Chrysalis begin to study this ultimate challenge to see if it's a realistic goal. From the coast of Crete near Knossos to the nearest island, Sant'Orini, is 72 miles, more than 3 times farther than the English Channel crossing, which had completely exhausted the pilot. Was such a long flight physically possible? To find the answer, they look first at potential engines. How much power could an endurance-trained athlete be relied upon to produce, and for how long? Steve Bussolari, an MIT assistant professor of aeronautics, is in charge of finding out.
The airplane designers asked us, how much power can a human pilot produce? And the physiologists said, how much power do you want? And the airframe engineers said, all the power we can get, how much can they produce? So it was clear that we had an unresolved design issue. So what we did was we went out and recruited athletes and tested them to determine how much power they could produce.
Okay, loads going up, keep good rhythm. That's good.
Dr. Ethan Nadell, a physiologist from the Pierce Lab at Yale University, designs a test in which the athlete rides for about 15 minutes under increasingly heavy loads.
Okay, loads going up now. Push hard, keep that rhythm. Good.
The rider consumes more and more oxygen as his power output goes up.
Loads going up now. Push through it.
Eventually, he reaches his maximum aerobic capacity, the point when his oxygen intake and therefore his power output can no longer increase significantly.
Push, 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 push.
Nadell knows that trained athletes can perform at about 70% of total capacity for several hours or more. But above 70%, endurance drops dramatically from hours to minutes. So 70% of capacity would be the level of sustainable power.
Περνώντας κάποιο τεστ σε στατικό ποδήλατο σε στάση recumbent, δηλαδή ξαπλωτή στάση, όπως ήταν εκεί και στο Δαίδαλο, πέρασαν κάποια τεστ σκληρά. Είχαν βάλει, αν θυμάμαι καλά, μια πίεση 4,2 βατ ανά χιλιόγραμμο βάρους για 4 ώρες. Αυτό ήταν το αρχικό τεστ.
Looking back in the data, Steve finds that at 70% capacity, the best athletes in this test produced about 3 watts of power per kilogram of body weight. Now the airframe designers have a starting point. But before they can fix the size and configuration of the plane, they have to decide how fast it needs to fly, because airspeed has a profound effect on power.
The power required of the aircraft's engine, in this case the pilot, goes as the cube of the airspeed. That is, if you double the airspeed, you have to produce 8 times the power to fly the aircraft. So you can see that it's very sensitive. Just a small increase in speed demands a lot extra of the pilot.
But the speed has to be tailored to the goal, a long flight over water in a region notorious for sudden winds. The faster the plane flies, the less chance it has of getting caught in bad weather.
So we have this trade-off between the size of the weather window, the amount of endurance that the pilot has, and the speed of the aircraft. And basically, we arrived at a compromise. As in all engineering design, it's always a compromise. We think that the pilot is capable of producing the required power for 4 to 5 hours. That translates to about 15 miles an hour for the airplane.
Everything depends on adapting the plane to the limited amount of power that the pilot can produce. That means that no power can be wasted. For the designers, the 2 things that most affect power are the plane's weight and the performance of the wing. The team's aerodynamicist is Mark Drela, an MIT graduate and now assistant professor of aeronautics. He designs the airfoil using a computer program he developed for his doctoral dissertation, a kind of simulated wind tunnel that allows him to consider hundreds of different shapes for the lift as well as the drag they produce. At some point, depending on the airfoil's shape, the stream of air close to the wing changes from smooth laminar flow to rough turbulent flow, resulting in profile drag. The transition should happen about 2/3 of the way back from the leading edge to minimize the problem. Once satisfied with the airfoil, the designer faces another problem, an unavoidable byproduct of lift called induced drag. Because lift results from higher pressure below the wing than above, air wants to flow around the wing tips from the bottom to the top, which creates vortices of air spinning off the tips. These vortices rob energy from the power plant by retarding the forward motion of the plane. Induced drag can account for as much as 3/4 of the drag on an HPA, which is mostly wing to begin with. The design team has already estimated the weight of the plane, and Drela knows that he needs 330 square feet of wing to produce enough lift. He can't eliminate induced drag, but he can reduce it with a long, narrow wing. It will produce the same amount of lift as a short, wide wing of the same area, but will spread its influence over more air, resulting in lower pressure across the span and therefore less violent vortices at the wing tips and less wasted energy. It looks good on the computer, but will it fly? That depends largely on how much it weighs. Wire braces could save weight by reducing the amount of internal structure, but that would create too much drag. So the long wing will have only one wire below to help prevent it from bending up in reaction to the force of lift. Most of the wing's strength will depend on its main spar. The problem is making it strong but light. That job belongs to Juan Cruz, a sometimes MIT student with considerable expertise in the field of advanced composite structures. He plans to use a new material called graphite epoxy, which has the strength of aluminum at a fraction of the weight. Strips of graphite fiber embedded in epoxy are wrapped around a form in layers based on calculated stress points. Later, the epoxy will be cured in an oven and the form removed, leaving an ultra-light graphite tube. This experimental material is what puts the whole concept of Daedalus within the realm of possibility. By the summer of 1986, the Daedalus team has moved into MIT's experimental flight facility at Hanscom Field outside of Boston, and is well into construction of the Light Eagle, a prototype for the Daedalus plane that will prove or disprove all the theoretical design ideas. The airfoil shapes are carved out of blocks of styrofoam on a hot wire cutting machine, which takes its instructions directly from a computer. This homemade machine guarantees a precise replication of Drela's airfoil design. After months of work, it's time to see if the wing is really as strong as it's supposed to be. "350 pounds of water hang from the spar to simulate the kind of load it must be able to take in flight. No graphite structure has ever been pushed this hard before, and if it fails, the project is in serious trouble."
This makes me nervous. Yeah, looks all right. Okay, here we come. That's it.
As the wing passes its first test, an amateur triathlete named Lois McCallan begins training as the first pilot. She's already proven her ability to produce the required power in the lab at Yale, and now she's learning how to fly. Lois will log hours of flying time in gliders and ultralights before she's ready for human-powered flight. Meanwhile, the designers are getting closer to having a plane ready for her. Except for a few metal screws, every piece of the aircraft is handmade. Mechanical designer Bob Parks has spent nearly 2 months building the gearboxes which will transfer the pilot's power to the propeller.
Ήταν ουσιαστικά ένα διαφορικό. Όχι, με διαφορικό ήταν το διαφορικό από κάρμπον. Και στις άκρες είχε κεφαλές αλουμινίου με δόντια. Η ταχύτητα ήταν ένας λευγές που έκανε μια συνεχή μεταβολή της κλίσης της έλικας, pitch control που το λέμε. Δηλαδή η έλικα να έχει μεγάλη κλίση, άρα να σπρώχνει πολύ αέρα, ή να έχει λίγη κλίση και να σπρώχνει λιγότερο αέρα και περισσότερες στροφές.
Mark Drela has spent at least 100 hours on the propeller alone. 20 hand-cut airfoil sections go into what is essentially a small rotating wing that will produce thrust instead of lift.
Η έλικα που ήταν έτσι το πιο δύσκολο κομμάτι της κατασκευής, γιατί και αυτό έγινε από κομματάκια αφρολέξ, διαφορετικού σχήματος που ενώθηκαν και επενδύθηκαν από κάρμπον. Είχε 3,5 μέτρα διάμετρο, μήκος δηλαδή, ήταν 3,5 μέτρα και βάρος 800 γραμμάρια.
One night in September, the drivetrain is ready to test. The theoretical phase of this project is coming to an end. Early one morning in October, the Light Eagle, wrapped in a skin of lightweight mylar, is rolled out onto the tarmac at Hanscom Field. Lois has been sealed into the temporary fuselage and is about to find out what it's like to fly under her own power.
All set. Set? All set. Okay, let's roll it.
As you're taxiing on the ground, you hear the landing gear rolling, and it's pretty loud. And all of a sudden, the noise is gone, and you think, my God, I'm in the air. And you just keep pedaling.
After 13,000 man-hours of work, the Daedalus project is officially off the ground.
Here we are, it works. You know, we can do this. It was just, you know, this is the moment we've been waiting for, and there it was.
Now it's time to test the limits of the plane and the pilot. In the high desert of Southern California is Edwards Air Force Base. Generations of aircraft, from the X-1 to the Space Shuttle, have proven themselves in the sky over this dry lake bed. And now the Daedalus team is here at NASA's Ames Dryden Flight Facility to escape the New England winter and to see how far their plane can fly. The Light Eagle has its finished fuselage with electronic instruments on board. A mast and temporary support wires have been added on top to protect the wing from damage during test flights. But the team must now face a troubling problem that they've known about for some time. At 88 pounds, the Eagle is 20 pounds heavier than it was supposed to be because the particular type of graphite they wanted had not been available. That extra weight requires more power to fly, more power than Lois is able to produce for extended flights. The engineers have done everything they can to improve the efficiency of the plane. Finally, they install longer wingtips to increase lift and reduce the drag even more. With the last technological card having been played, Lois sets out to fly the Eagle as far as she can.
My greatest fear was disappointing the group and not being able to perform in the plane the way that they wanted to see it perform. And that was a real concern. I didn't want to let them down.
Okay, your attitude looks good. Maintain level attitude. Keep the power in, keep it taxiing.
Stop here, Ethan.
37 minutes later, she sets down, having flown a little over 10 miles around the lake bed. It's a world record for human-powered flight by a woman. But she's reached her physical limit. For the team that hopes to fly 72 miles across the Aegean Sea, there's no alternative now but to look for a stronger pilot. They find what they're looking for in a 25-year-old medical student named Glenn Tremmel, a good athlete who also happens to be an experienced pilot. In the lab, he produces 13% more power than Lois. It's a small difference, but it may be enough to put him over the long endurance threshold when flying the Light Eagle. He proves that it is by flying 37 miles around the dry lake bed with energy to spare. It's the longest flight ever in an HPA, and strong evidence that the flight from Crete is possible. Lois stays on as a member of the team, but is no longer a pilot, a victim of the unforgiving physics of flight. Six months later, the Hanscom Field hangar is active again. Because of the ominous possibility that it may take more than one try to make the flight from Crete, 2 Daedalus planes are under construction. Harold Youngren, a veteran of the team's early human-powered flight days, has taken a leave of absence from his job to supervise the engineering. Drawing on the experience with the Light Eagle, he's determined to achieve perfection with Daedalus. Every unnecessary gram of weight is stripped away. Even the adhesives are rationed out. The overall strength of the plane is reduced to the bare minimum. This time they have the right kind of graphite. It has greater stiffness, so they can get away with using less of it, saving even more weight. Each plane takes 15,000 man-hours to build, so more undergraduates have been recruited to help out. With all the refinements, the planes should be under 70 pounds. Even so, they aren't taking any chances with the power supply. 4 world-class competitive cyclists have been recruited to fill out the pilot team.
That one's a Porsche and this one's
Greg
a Ferrari.
Zach, Frank Scotia, Eric Schmidt, and Canello Canellopoulos all have greater power and endurance than Glenn Tremmel, but none of them have his flying experience. So while the Daedalus planes are under construction in Massachusetts, the Daedalus pilots are in California learning to fly. They also keep up an intensive training regimen, cycling at least 400 hard miles per week. But even this kind of conditioning won't guarantee success. The estimated flight time from Crete has increased from 4 to 6 or even 8 hours due to the likelihood of headwinds. A flight that long presents serious problems no matter how good the condition of the pilot. After 3 to 4 hours of heavy exercise, the body depletes its reserves of glucose, an essential energy fuel. When this happens, power output drops dramatically. For the Daedalus pilot, that would mean a splash landing in the ocean. Dehydration would also be a problem on a 6-hour flight, since the pilot will sweat more than a quart of water per hour. Dr. Nadell solves both problems at once with a drink designed to replenish glucose, water, and salt at the same rate that they are lost. With the help of this drink, each pilot is able to complete a 6-hour endurance test at flight power. December and January are the wettest, windiest months in 30 years at Edwards Air Force Base. The first of the 2 Daedalus planes was finished weeks ago and shipped out here from Massachusetts. But the weather has put flight testing a month behind schedule. The team and planes need to be in Greece and ready to fly by mid-March in order to catch one of the few spring days when the weather will be right for a record attempt. It's now early February. Every inch of Daedalus is meticulously crafted and a marvel of lightweight design. But it's so fragile that a gust of wind could tear it apart.
I think that the wind is definitely too much. I mean, I think we should scratch.
4.8, 4.95.
The builders are extremely protective of their $1 million airplane.
It's starting to gust. All right, let's put it in.
They take no chances with the weather, even though they've had only a fraction of the flight time they'd hoped for. No one wants to risk an accident this late in the game. Then, just 2 weeks before the scheduled departure for Crete, everyone's worst fear is realized. a team member's 8mm camera records the action.
Full left rudder and keep the nose down, keep the speed up. Hold in that full left rudder, hold in the full left rudder. Wow. Put the nose down, speed it up slightly, not too fast though, not too fast. Keep the wings level, keep the wings level. Left rudder, full left rudder, full left rudder, full left rudder. Just flare it up.
The pilot is okay, but Daedalus is not. 24 hours later, the engineers gather at Hanscom Field to watch the tape and figure out what went wrong.
Slightly, not too fast though, not too fast. Keep the wings level, keep the wings level. Left rudder, full left rudder, full left rudder, full left rudder. Just flare it up.
Well, no, that's pretty hard to tell. It really is.
After so much work and attention to detail, how could something like this happen? Was it pilot error, mechanical failure, bad luck? Eventually, it's decided that the problem had been built into the plane. Most airplanes, including the Light Eagle, have ailerons, movable surfaces on the wingtips, that the pilot uses to control bank angle and maintain level flight. But to save weight, the Daedalus was built without ailerons. Instead, it was supposed to have more dihedral, or upsweep of the wings. If there's enough, this tends to keep the plane level. It was to be done by lengthening the wire underneath, allowing the wing to bend up in reaction to the force of lift. But because of disagreement within the design team about how much was enough, the Daedalus ended up with less dihedral than it needed. And when a gust of wind lifted one wing, the plane went into a slow spiral dive, which the pilot could not correct.
Left rudder, full left rudder.
We have an airplane which is all smashed up, but about 2 weeks worth of work to fix. The improvements, and in some sense, are obvious. I mean, the problem with all these things is that accident like this is that hindsight is 20/20. We're going to increase the dihedral. We're going to do some testing with the Light Eagle with increased dihedral. That'll give us the information we need to either say, well, this is not going to work or it will work, and just go ahead for grease with that. We don't have much time. At this point, we're under a lot of pressure. I mean, in order to finish the current ship, which is out in the hangar, we have probably another 600 man-hours worth of work to do in a very short time. And the problem is getting rapidly to the point where it has to be done by very few people, too, because they're the only ones who are qualified to do the work. But that ship will be finished by our elite crew on the middle of next week, and then go out to California.
From now on, there's very little sleep for the building crew. The move to Greece has been set back a month, and if there are any more delays, they won't make the spring weather window this year, or perhaps ever. By the end of February, the new plane, called Daedalus 88, is in California ready for testing, while Daedalus 87 is back in Boston being repaired. From now on, everything has to work perfectly. As it turns out, the suspense is short-lived.
That's good.
With more than twice the dihedral of Daedalus 87, Daedalus 88 seems to be perfect. It's finally clear that the plane has reached its ideal form and is ready to take on the myth it was named for. On the evening of March 26th, a C-130 transport plane provided by the Greek Air Force is on its final approach into the Heraklion airport on Crete. Inside are the two Daedalus planes and the Light Eagle, outboard motors, spare parts, computers, and all the other necessities of human-powered flight. From this point on, the Daedalus project is a bilingual, bicultural effort.
Okay. We get later. I think for one, it's very light. No. This is okay.
Μα φωνάζαμε για από το ξεφόρτωμα του σε 130 τα κυβότια Μην τα κουμπάς. Μιλάμε, ο φόβος ήτανε. Ο φόβος. Είχα τρελαθεί, είχα πάθει ψυχή. Μου είχαν μεταφέρει μια φοβία και προσπάθησα να το περάσω στο Logmaster. Καταρχήν το Logmaster ήταν ο υπεύθυνος φόρτισης στους 130 του αεροσκάφους. Μετά οι επίγειες, ας πούμε, δυνάμεις σου βοήθησαν. Μην τα κουμπάς. Μην πρόσεχε. Μην ανασένεις. Μην κάνεις.
Αν δεν έχει αέρα πρέπει να πάνε τώρα τους βάλουν, γιατί μετά εδώ δεν έχουμε να τους βάλουμε.
The Greeks embraced the project with a passion. Every Greek child knows the story of Daedalus and Icarus. Here, it's the impetuous son Icarus, not Daedalus, who is honored as the mythical pioneer of flight. So, on the nearby island of Icaria, the Hellenic Air Force Icarians welcomed the Daedalus team to Greece. The project is now very much in the public eye. The Greeks are providing extensive support, and anything short of total success will be hard to explain. But back on Crete, the difficulty of what they're trying to do begins to sink in. A hangar is set up to house the planes beside the runway where Daedalus will take off. The next day, gale force winds nearly blow it away, along with the unassembled plane inside. In fact, the wind seems to blow constantly on Crete. Looking out to sea, it's difficult to imagine a day calm enough to fly a human-powered airplane. A team of meteorologists has been studying the weather along the flight route for 3 years, and the statistics say that there should be 2 or 3 calm days in April before it gets too hot to fly. Somehow, those numbers seem more theoretical here than they did back in Massachusetts.
Επιλέχθηκε από το Μάρτι και μετά, γιατί είχαν κάνει παρατηρήσεις χρόνια πριν ότι στο Αιγαίο υπάρχουν 3 με 4 ημέρες μέσα στην Άνοιξη που είναι το κρητικό πέλαγος ήρεμο. Είναι πολύ σπάνιο φαινόμενο, δηλαδή να μην έχει αέρα. Και αυτές είχαν βρει ότι είναι 3 με 4 μέρες μεταξύ Μαΐου και Απριλίου.
The pilots are cycling up to 100 miles each day in the mountains. To prepare for a major endurance effort, an athlete has to train hard and then taper for a day or two before the event so that he's rested, but still in peak condition. The 5 pilots are on a rotating schedule like baseball pitchers, so that someone is always ready. The one who makes the flight will be the one who's up in the rotation on the day when the weather is right.
Από τους άλλους είχα το διαφορετικό ότι σε όλα τα φυσικά τεστ ήμουν καλύτερος. Δηλαδή έβγαζα πάντοτε τα τεστ με χαμηλότερους σφυγμούς από ό,τι οι άλλοι. Είχα μεγαλύτερη εμπειρία και σε αγώνες. Έτσι. Και μάλλον είχα και την... με εμπιστευόταν περισσότερο ο διευθυντής πτήσεων. Ότι θα ήμουν ικανός να βγάλω την πτήση ανώδυνα.
To replace the energy they burn off in training, the pilots have to consume 6,000 to 7,000 calories a day, more than 3 times what the average American eats. Carbohydrates account for 70% of the diet. A typical breakfast includes 3 different kinds of cereal with honey, half a loaf of bread, butter, a quart of milk, hard-boiled eggs, cheese, and several pieces of fruit. It took a professional nutritionist to convince the kitchen staff that each pilot would need this much food for dinner every night. With human engines, it's important to keep the fuel tanks full. The Hotel Exania in Heraklion has now been taken over by the Daedalus team. In a corner of the lobby that serves as headquarters, Steve Bussolari's weather reports have become a daily ritual.
The bridging that we expected to take place of the high pressure over the area has in fact taken place.
The news is starting to get better. A high-pressure system is developing over the region, which could result in calm weather for several days.
So, in view of that, I think that tomorrow is definitely going to be a possibility.
It's decided that the team should be flight ready in the morning.
Okay, great.
See you at 3 a.m.
Get up, man. It's flying time. Let's go.
3:30 a.m. It's still hours before sunrise, but there's a lot to be done. The first boat crew heads out to get wind measurements offshore.
We have about 1.5 meters per second from...
They stay in touch with Steve, who's been up most of the night watching the weather.
What's the sea state?
Another crew assembles the plane at the airfield, while today's pilot, Greg Zach, warms up, unaware that his chances of flying today are already starting to slip.
I don't think we're going to go. It's my feeling now. I don't like the weather situation. I don't like the fact that we don't...
Just offshore in the command boat, Steve has had reports of high winds aloft at Sandorίνη.
Of the dip in winds.
Everyone stands by, waiting for his final decision. Greg has been sealed into the plane and pointed down the runway, but Steve has already made his decision.
Dædalus, this is command boat. We're going to scrub the flight. I want you to have get the pilot out, disassemble the airplane.
With so much riding on the decision, it's a difficult moment for Greg and for Steve.
We've just started waiting for the weather. Do we jump at the first day that comes along, or do we look for something better? Maybe today was the kind of day that we would have gone if we'd been waiting for 6 weeks.
When I cross over.
When you cross over here. Now,
Frank Scotia is up in the rotation for tomorrow, and Steve goes over the takeoff with him.
let's start with the worst that could happen first, okay? You hit this stuff and you lose control. The one wing picks up and it slips like crazy.
The problem is the 140-foot drop off the end of the runway, which could cause air currents that would make the plane hard to handle.
As you come over the edge here, you may feel it start to settle with one wing. Just give it some rudder. You got plenty of room.
It's the kind of situation that would be routine for an experienced pilot like Steve, but it could be trouble for less experienced flyers like Frank and the other Daedalus pilots.
Το αεροπλάνο φαίνονταν ότι αντέχει, δεν το είχαμε δει και στην προπόνηση. Αυτοί φοβόντουσαν το σημείο της απογείας που ήταν 37 μέτρα ύψος. Είναι σαν βράχος πάνω από τη θάλασσα, το αεροδρόμιο του Ηρακλείου. Και αυτό μόνο φοβόντουσαν, που ήταν ψηλά, αν γινόταν κάτι εκεί θα μπορούσε να σκοτωθεί, επειδή ήταν πολύ μεγάλο το ύψος.
It's just one more of the many things that could go wrong.
What we're attempting here is not something that's a shoe-in. I think that we have a real chance of failure here, and but it's if it were easy, I don't think we'd be as interested in it.
Another early morning at the airfield, but this time there's a strong feeling that the moment has arrived.
I think this is it. I think today is the day.
I'll see you out of the water.
Okay, hopefully you'll see me at the beach as well as out on the water. All right.
Make it a good one, Frank.
Okay.
One from Mary and one from me, okay?
Okay.
I know you're going to make it.
Roger.
Okay.
An hour later, Frank is ready to go. But out on the command boat, Steve's optimism has disappeared.
Okay, I've made my decision. We're going to scrub it. Sorry about that, Frank. Let's
At the last moment, the wind suddenly picked up. Now it's Frank's turn to deal with the adrenaline he'd pumped up for the flight and try to get his mind back on training. With the engineers rushing to get the plane out of the wind, the only sympathy comes from his fellow pilot.
I think that maybe the rest of the people in project, not all of them, but a lot of them have a hard time appreciating what the pilot has to go through and what some of the psychological aspects of getting ready to make that flight are. You can't do that very often. That's everything you have to be ready for that.
Υπήρχε τεράστιο άγχος, γιατί υπήρχε τεράστια πίεση όλο αυτό το διάστημα, επί μήνες, κάθε μέρα πίεση, ψυχολογική πίεση σε όλους, όχι μόνο εμάς που πετούσαμε, αλλά και όλα τα παιδιά του προγράμματος είχαν ψυχολογική πίεση στο να σηκωθούμε, να κάνουμε, να ετοιμάσουμε, να φτιάξουμε αυτό, να κάνουμε εκείνο. Κάθε μέρα υπήρχε πρόγραμμα.
As it turns out, no one will have to do it very often. For almost 3 weeks, it's so windy that Daedalus never leaves the hangar. The pilots have no problem staying busy. There's not only training, but the attention of the press to deal with. The Greek pilot Kanellos is very much in demand. He's already well known as the country's top cyclist, and his status on the Dædalus team is a big story in the Greek press, especially since there's no guarantee that he will make the flight.
It's an American project, and there is a Greek in there, and now we are in Greece. It's normal focusing on him, because they expect of me doing the flight. They cannot think about doing the flight someone else. That's a problem.
Οι Αμερικανοί βέβαια ήθελαν να είναι Αμερικανός για λόγους marketing και τα λοιπά, για να γίνει η πτήση.
It may not be popular with the press, but the rotation continues. 2 days on, 6 days off for each pilot, and the training never stops. The spring weather window is getting smaller every day. In a few weeks, it'll be too hot for the pilots to fly, and the project will be out of money. Steve spends most of his time at the Air Force weather station or on the phone with meteorologists in the United States, trying to make sense of the unpredictable Aegean weather.
But for Thursday morning, it's starting to move, and by look at it, becomes a trough.
Finally, in the third week of April, the forecast starts to improve. On Friday, April 22nd, Steve tells the team to be flight ready Saturday morning.
These gradients are very, very light.
Kanellos is up in the rotation.
Looks good, Yannis. Feels right to me.
Early Saturday morning, the weather appears to be perfect. Cool temperature and very light winds from the south. Kanellos nervously awaits what he hopes will be the triumphant final act of the Dædalus project.
Command boat, this is takeoff site. Just got an update from the inflatable. That was 1.6 to 2.1 meters per second from the south.
Okay, fine. Well, we're gonna go.
It's time for Kanellos to take the stage, and he does it with an inside joke for the engineers.
Oh, lightning holes.
Surprise of the day.
The holes in his shorts are his gesture toward the obsessive drive to reduce weight in the airplane.
Takeoff site, this is Steve. We got a south wind at Sandorini, we got a south wind here, we got a south wind at Dia. I think we're in good shape.
If it holds, the light tailwind from the south will increase the plane's speed, shortening the flight time. But Kanellos still must carry a heavy 6-hour supply of the energy replacement drink, just in case.
Okay, I'm looking at the smoke now. We got a fairly good downdraft coming over that lip, and I'd like to see him 3 or 4 meters above the runway surface when he goes over that.
Yeah, okay.
Are you ready for takeoff at this time?
Over.
Okay, Steve.
Okay, Kanellos. Ela. Petaxi. Take off. He's up. Well, the research part of this project is officially over. Beautiful, no problems at all over the lip. You look awesome. Really good, Kanellos. Looks great. Awesome! Here we go! Woohoo! Orea, Kanellos. Orea. What's your airspeed, Kanellos?
14.
14, that sounds good. What's your heart rate, over?
145. Up there. Better than perfect. My pulse now goes to 30s, upper 30s.
The Greek Navy, Coast Guard, and Air Force are on hand for emergency support and to keep the pathway clear. But Dædalus doesn't seem to need any help. The plane and pilot perform beautifully, and with the boost from the tailwind, the only concern is that it will all be over too soon.
You're making about 18 knots, 18 knots. If you keep up this speed over the bottom, it's only 3 hours to Santorini from here, which is a piece of cake. But we'll keep you posted on the speed. Over.
The only landmarks now are the world records falling one by one. First down is the Gossamer Albatross straight line record of 22 miles. Then it's the Light Eagle's absolute distance mark at 37 miles. Finally, the Gossamer Albatross duration record at 2 hours and 49 minutes. But the records have become almost a footnote to the experience. The greater satisfaction now comes from the realization of a dream, a modern mythical creature, half man, half machine, living out the earliest fantasy of flight.
Και πραγματικά λοιπόν γίνεται το εγχείρημα και εξελίσσεται όπως το είχαν προγραμματίσει, με ένα Κανέλλο Κανελλόπουλο να σκίζει πραγματικά στον αέρα. Να πετάει λες και είχε μηχανή μέσα. Λες και είχε μηχανή.
Almost 4 hours into the journey, Daedalus approaches its final goal, the island of Santorini.
Okay, Santorini Beach, this is Command Boat. We're going to want you to get ready to lay the smoke for us.
It's just over those boats.
The flight has been flawless, almost routine. Canellos could probably keep going for hours. But the gods are not going to let the mortals off so easily. The wind is suddenly picked up.
Steve, the smoke is coming out.
Canellos will have to come in parallel to the beach for an upwind landing.
Okay, let's get the beach clear, beach people. And Canellos, I want 20 degrees to the right. Give me a good right turn. I want to give you plenty of room to approach that landing site. Over. Okay, don't worry. I never worry. Okay, they look good now. Okay, we've got a big headwind here. We're barely making any way at all. Canellos, that looks good. Maintain this heading. There are people running on the beach now. I think there's a lot of people running. Okay, well, don't worry about them. We're going to land where they aren't.
Caught in the strong headwind, Canellos is having trouble approaching the beach.
Okay, maintain that heading. Maintain that heading. I want the wing runners right there. He's going to set down almost vertically. Okay, you're looking good, Canellos. A little bit of a right-hand correction. A little bit of a right-hand correction. Easy, keep the... Uh-oh. Uh-oh.
A gust of wind snapped the tail boom and then the wing, turning Daedalus into Icarus. The first thought is for the safety of Canellos. But before the crowd can reach him, he's out of the plane and on the beach, looking refreshed after his swim. The records have been set and no one is disappointed. And while the effort may seem to be short on practical benefits, a pursuit like this can inspire progress in technology by changing ideas about where the limits lie. If a plane can fly with a quarter horsepower engine, what else is possible?
How you doing? Oh, pretty good. Would have been a little nicer if we hadn't broken it up, but it's good to be here. It's a long flight.
That was easy.
Huh?
That was easy. The landing was the most difficult part.
Ah, well, we had not the right weather.
Yeah. Hey!